So let's go into the Q&A session. Bernie has a question. So I will ask Bernie to unmute. Up in Vancouver, right, Bernie?
Calgary, pretty close, Alberta.
Do you guys have a heat wave up there?
Oh, yes, we definitely do.
Yeah, because I'm in the Seattle area and it's sweltering here.
Oh, yeah, it's hot and dry, which is nice for Canada, but scary. It's the beginning of the summer. My question for Brian is, has he ever seen the YouTube channel VE Project 1? And it's a Chinese channel that does a lot of similar, they call them like overbalanced wheels or gravity wheels, but what it really, or perpetual motion, but that's not what it is. That's wrongly labeled, because what it actually is engineering of an open system bringing more motion or more energy in. So that to say perpetual is wrong because it's open source, bringing more and more energy in, right? And when I first realized that there's something to these technologies and designs, is that the geometries of them started showing up in a lot of the crop circles that are the more unexplained crop circles. And I don't know if you've seen, there's also another researcher out there in Italy that has run computer simulations of these crop circled geometries. And the machines that were coming out of the devices are very, very similar to what you're working with and making there.
Yeah, I've seen a lot of that information. To remember all the different ones that I've looked at would be just astronomically unrealistic, because there are so many out there. A lot of them do work. There are operational systems, but they're not really as efficient as they need to be to really be moving forward. I know there's a couple of systems out there that the guys are working on. Steve Hampton's system, his is showing some of the best progress at this point. But yeah, I have seen the VE project. I don't remember what it was. I was looking at it. When you talk about comparing that to some of the designs of the old perpetual motion machines that people were trying for so many years, you're right. There's a lot of similarities, and I think that it's more in the geometry. No, they don't work as perpetual motion, but they can be built in such a way that they can cause propulsion. So great question. I really appreciate that.
Thanks, Brian. And yeah, I bring those up also for anyone that's skeptical of your designs to see for themselves, to look into that there's lots of other models, some more simplistic, obviously not as efficient as what you're working with, but stuff that people can experiment with themselves and see that there's actual practicality behind it.
And Bernie, thank you. I should mention, so thank you for having the camera on. It looks like you're off to the side of it. I don't know if that's intentional, but there we go.
Sorry, I had, when Jeremy was having issues starting there, I had it at some paintings that were of nude charactered girls. So I'm at my girlfriend's house, so we had to rate it there, PG rate it.
Yeah, PG rate it. Thank you, sir. Thank you. Yeah, well, I don't want to get in trouble with YouTube. Although, I do want to ask at some point, I want to ask Bernie if Bernie, have you ever thought about taking a stab at graffiti art for the APEC conference?
Absolutely, my friend. We will talk more, but through my business and clothing lines, I have hundreds of artists that I work with and ridiculous amounts of designs and talent.
Yeah. Okay. Well, so let me go. Let me see who's next. Michael, sir.
Hello. So that was pretty cool. I was impressed by that. I think so. I'm curious. Few questions. You were talking about at one point about the when it was moving forward, that the angle between the planetary gear and the apex was something you said
before center, yes.
And it was 20. You said you were talking about 45 degrees or 20 degrees or
in the 20 to 45 degree range.
Okay, so my question is,
the impact would happen in that area. Okay, go ahead. I'm sorry.
So my question about that is, have you tried putting the assembly on a slope?
Yes.
And does that affect that angle? I mean,
no, that does not affect the angle unless it's running so slow that gravity is actually pulling back on the weights. If
it's going faster, so so that's what I'm curious, is the effect of the direction of gravity on the results.
If you bring the RPM of the unit up, I haven't tried to make it pull straight up or straight down. I'll be perfectly honest.
But you could try that. You could put it on a slope and see if.
Oh, absolutely.
And then measure that angle and see if you could tweak the angle. So basically, what I'm thinking about is just applications in my mind.
Right. Sure.
Something like, regenerative braking system.
Yes.
Okay, where you're going down a hill and you add that extra torque in there, and that's gonna create power for my little generator. Okay.
Right.
On each wheel.
And that is entirely possible. I haven't done any experiments with regenerative power from it. On the other hand, I have actually mounted it backward and used it as a braking device. And it will work just as well as a braking device as it does a propulsion device. So that's why when I'm talking about being able to turn that center gear around and change the direction of thrust, that to me would be a game changer as far as use in a motor vehicle, whether it's on the ground, in the water, in the air, or in space. It wouldn't matter.
One other application I was thinking of is if, even if it's in that horizontal configuration.
Right.
Is there any way you could use this for like a pump?
I'm sure you probably could. Could.
Pump power.
Sure.
Air, whatever. Just for pump storage.
I know that there's been some experimentation with similar units that have mounted them on wheels inside another carriage and had them push on spring loads, which I thought was pretty interesting. I don't see a huge amount of propulsion coming from that. It seemed like a good idea. It seemed like the springs would store some of that inertial propulsion, but they don't seem to.
Dissipate.
Yeah, it dissipates too much of it. I think that they would have to be a very, very efficient and very stiff spring design. Otherwise, just the heat dissipation alone is not going to allow it.
So would you say the impact is the key to the propulsion?
Impact and speed differential. If it doesn't change, if you don't change the speed of that weight moving, not just rotational speed, but actual velocity, by moving it out away from the center and then back towards the center, you're not going to get enough impact to have a propulsion unit.
So it's actually acceleration. You're accelerating.
Right. You have to accelerate and then you have to decelerate. You have to accelerate and then decelerate. So you have to have that fourth dimension to that system, which is the time part of it. Faster, slower. And then start adding in, okay, now we've got the centripetal force, which is going to pull us forward, which is where a lot of people just stop. Quite honestly, that's where a lot of people have looked at it and tried and well, yeah, it might try to work, but it doesn't work well, and that's where they stop. Well, you know what? You need to instantly change the speed of that and use that centripetal force in an impact. And now you've got some serious power being built.
Yeah, it's inertia.
Sure.
Okay, thank you for your
my ears perked right up when you said the quantized inertia. I'm like, yes, that's the word.
Well, that's really Mike McCullough's term. I actually call it gravitomagnetism, but because it's got two different you got positive and negative inertia essentially.
Sure, absolutely.
Awesome. Okay, well, thank you, Michael. Brian, the thing that I love about your work is it's heavy duty, right? Because you see stuff online and it's like little, and those are wonderful. They're great experiments. I mean, there's nothing. I don't want to sound negative at all about them, but right. You see these really lightweight, tiny little devices, and they'll move across the table. And then, the first time I saw yours, it was like these massive gears, and I was just like, you know what? If you're gonna do it, that's the way to do it. So
go big or go home.
Yeah, there you go.
I mean, this thing is not lightweight in any way, shape, or form. Every one of them is weighed in at least 45 pounds or more. That's without carrying a battery, without carrying anything else, without any external stuff attached to it.
It almost
they're pretty heavy.
Yeah, to me, but in an engineering sort of way, in a mechanical sort of way, I think it almost looks artistic. It's kind of like a work of art. And I think that the heavy duty gears, right, the heavy weights, the way that it's built, kind of adds to that.
Right. So. I mean, it would have been nice to have custom made machine shop spur gears. I mean, I could set up some machines and start building them, but I would spend weeks out in the shop making gears that I know I'm going to break. Yeah. These things, no, they're not super efficient, and they're certainly not quiet, but they're cheap. For $3, $4, I can buy these things all day long and throw them together, and the paint for them cost more than the gears ended up costing. So I can blow them up, re-weld them, throw them away. I don't care. Make hockey pucks, whatever. It doesn't matter. And that was really part of it. The very first one, my whole goal was to be able to show people how to build something that would work. If you have a halfway decent auto shop or machine shop, that you can put together for less than $350, period. Where can you build anything for less than $350, and especially not an emerging technology?
Yeah. Well, so let me see who is. Oh, well, Bernie has his hand up again. I did want to see Ross Small. Ross?
Sorry, one thing, Tim.
Oh, yeah.
Just before you go on, are you streaming this live to your YouTube right now? Because Jeremy had to end it on the Alien Scientist. I know that you edit them and release them later.
Yeah, I'm going to edit and release, but I'm not streaming. So the stream is probably ended then.
Yeah, do you mind if I connect it through my Yard House and stream it on my channel? I don't think it'll affect anything you're doing right now.
Oh, go for it, man. Go for it. Yeah, I always edit these and I cut them up, right? And that way it makes
great with that. Absolutely.
Thanks. Yeah, it takes like 8 hours to do each one usually, right? But
sorry, I'm going to interject one last thing with Brian. The VE Project 2 really good videos they did. One is Aristotle's water wheel or something like that, and it's 3 sealed balls with water within each other that keeps going. And another one is Da Vinci's design of the overbalanced wheel. They're just designed.
Those I have seen. I'm familiar with those. I can picture them plain as day. Yeah, the geometry is similar. There's no question that the geometry is similar. But this is propulsion. This isn't over unity in any way, shape, or form. We're putting power into this thing and getting power back out of it.
Exactly, right? And like yours are definitely way more advanced and efficient and stuff. It's just for people getting into it to wrap their heads around the mechanics and the possibilities and the working of it. It's a good place to start.
Oh, it's an outstanding way to start without spending a tremendous amount of money. When I started checking in on gears of that diameter, the first set of prices that I got were in the $200 to $300 range per gear. You know, later on, I did find some other folks that would make them for a lot less. I mean, I could make them for a lot less myself, but I'd spend months in the machine shop doing it. You know, and there's just no point for something that it's a proof of principle more than it is anything else.
Yeah. Well, let me ask if Ross Small wanted to ask. Ross posted a bunch of stuff in chat. He was talking about. Let me see. Let me see if he wants to unmute. Looks like he has his camera on. Hey, Ross.
Hey. Yeah, I actually know Bryan. I'm actually collaborating with him a little bit on another side project. So
there you go.
Yeah.
Yeah. I noticed he said one thing. He said, you know, the 2 weights work better than, I guess, 3. And that I mentioned that actually makes sense because a lot of things in the universe seems like they balance in pairs. And I think of it, the most simple gyroscope, you know, most gyroscopes have you know, a million different weights around the wheel. The most simple gyroscope you need is just 2 points. You need at least 2 points. You need a center of gravity and 2 points. That's it. And they're just dancing around. So that's basically, in my opinion, is the balance of the universe. And this is nothing to do with, you know, free energy or anything like that. Perpetual motions machines. This has nothing to do with this. Like, it actually requires an input of a lot of energy. So that's the whole point. These systems, you have to input a lot of energy, and that actually is, my opinion, what's making the machine move.
Oh, absolutely. Yeah. That energy is exactly what's making the machine move. And an interesting side point, the double decker that I used the power drill to power it up, that was running, you know, 20 to 30 amps at 12 volts. The motor design of this little bicycle motor is so much nicer that with the speed controller, you know, I'm down to 5-6 amps, you know, at maximum power. So we're actually in pretty good shape. You know, our power curve has gone a long ways from where we started.
Mm.
So real quick, like, a really simple rocket, you know, this is what we're trying to defeat. We're trying to get rid of rockets and go to something else, electronics. That's the whole point of this, eventually, to get rid of rockets and have electric propulsion. And like he said, this is supposed to be impossible. This is supposed to break the laws of physics. I don't think it does, but that's the end goal. So a simple rocket is like, you know, a thing, and it shoots out a propellant in one direction, and the rocket goes in the, you know, obviously. With this types of system, the mass is just keeps spinning around in a circle, and you're never losing it.
Right.
But, I mean, it's the same concept. You're moving mass in a circle. You're just not moving it in a straight line. But
and if you really want to think about it that way, we're using a propellant. It's just that our propellant is electricity. Yes, it's going away. It's just not being output in a single direction, like we talk about with a reaction drive of a rocket engine.
Yeah, like the 2 point, like I'll say the simplest gyroscope, as 1 point goes up, 1 point goes down, and 1 point's going right, 1 point's going left, and then 1 point's going down, 1 point's going up. So they're always doing the same equal and opposite thing. So you have to pulse it at the right moment to always get your energy to go in a certain direction, and then the craft will go in the other direction. So that's what's happening here. You're moving energy, and you got to remember, energy equals MC squared. So you're just not, instead of moving mass out of the craft, you're keeping the mass in the craft, but you're moving energy at the right pulses. That's basically what's happening here.
Right. And you know, people all they want constant propulsion. They don't want pulses. But if you look, the only thing that doesn't give you some sort of pulses in any kind of a propulsion system would be a rocket engine. Even jet engines, they inject fuel, they light it. They inject fuel, they light it. Automotive engines, boat engines, reciprocating piston engines, it's all pulses. Those pulses can be measured with a pressure meter in the exhaust. They're smoothed via a flywheel, so you don't feel them when you're driving down the road. And that's really what we're after here. At this point, we're not going to get rid of the pulses. We just need to smooth it to the point where it's a nice continuous push. And that's kind of what we were talking about with our little side project, that collaboration is the way that this has all got to go. If people can't get together and trade ideas and try to upgrade and increase their own knowledge, I mean, it'll never go anywhere. So I really appreciate, your help on that, Ross.
Yeah. Oh yeah. We have something big coming up. We're holding our cards close to ourselves for now, but we got something else coming.
Right.
But the idea is that when he has a video of his machine hanging from the pendulum, and this is like, I guess, the gold standard from NASA. And I believe he's right. It is actually moving in a certain direction, but to really prove to NASA, you have to make that thing stay, like move and stay there and never swing back. It just would stay there for like over a minute in probably a 45-degree angle. That's my opinion. Otherwise, NASA and all these other people, I believe they're probably not going to take it seriously. So
even then, they may not take it seriously. I've met some of these engineers that you could argue all day long that the sky is blue, and they'll say, no, it just appears that way. It doesn't matter. It is what it is.
It sucks.
It does. It sucks. But you know what? That's why I'm not trying to prove anything. I make it very, very clear. I am not trying to prove anything. I am demonstrating what I have found works. Plain and simple.
There you go. Yeah.
Yeah. And he has another video where he puts a floor that actually the floor can move. And
right.
So his machine moved without pushing the floor in the opposite direction. When I saw that, I'm like, okay, it's got to be doing some type of thrust, because if it was pushing against the floor would have gone, in the opposite direction, but the floor stayed still and his machine went one way. So
yeah, absolutely. And it does. It works that way every time. There's no question that it's got its own propulsion. It's not pushing against any sort of stiction or anything. It has no physical connection to its surroundings. That's really the most accurate way to say that. It has no physical connection to its surroundings, and yet it moves.
Yeah, in my opinion, I think the best way to explain it to these, normal physicists is you're going to have to say somehow you're not breaking the laws of physics. You're just moving energy. That's the best way I think I can explain it. Is right. Einstein is correct. You say, yes, Einstein was correct. He said, he said equals at MC squared.
Yeah, I don't want the Einstein police to come down and write me a ticket, so I'm not breaking any laws of physics.
Yeah, I mean, energy is mass. It's the same thing. E equals MC squared. It's the same thing. So
if we can put energy into a mass to make a mass move, then we should be able to move a mass and get energy back out of it. There's no reason that we can't change the direction of the push of that energy, and that's all we're doing.
Yeah.
Well, so let me see who else has questions. Ross, let me see. Thank you for that one. Let me see who else has. Sorry, Todd and Jason are having a discussion in chat, but they're talking about EM versus gravity waves, which is totally different. So, but yeah, let me see who else has questions. Michael, do you want to ask again? Go for it, sir.
So let's just I'd like to do like a little thought experiment about what's actually happening at I guess what we would say the planetary gear is what's actually physically moving the cart, correct? And if you think about what's going on, you were just kind of described it's like it's making is the inertial energy, is the center of mass of the planetary gear moving forward or backwards, I guess is the question. You know what I'm saying?
Right. The planetary gear is a reaction point. And that's really what it is. It's a reaction point. So when the whole unit is propelling forward, that planetary gear is trying to push backward. Because it's a pivot point. That's really all it is.
So it's actually in front of the gear. You could think of like get down to the nanoscale of the atoms in the planetary gear, and we're these atoms, right? We got these electrons and our protons. So the electron cloud is like getting kind of egg shaped, right? Sure. And so what you're saying is that, so the electron, and then towards the left of the cloud, of the electron cloud, that's where the protons are. Okay, so the center, and that's where the center of mass is. So the protons are all like pushing to the left, and the electrons are going to the right. I mean backwards. I got it. The electrons are going to the left, and the protons are going to the right. Is that a way to think about it?
It can be. It can easily be a way to think about it.
So now I'm taking that and saying Albuquerque, Albuquerque's warp drive. So what we're saying is in front is expanded space-time and behind is denser space-time, because the denser part is the protons.
Right.
So essentially, if we think about it at the quantum scale, what we're seeing is we're engineering space-time in the vicinity of the planetary gear.
We could be. We could easily be. The thing to keep in mind, if you bring up the videos of this thing running and run them at like quarter speed, you'll really see the exact moments of inertial switchover when the inertia actually starts moving the unit. And with the weight that's hitting the center pin, all of the propulsion at that point is coming from the weight and the center pin. Absolutely nothing coming from the gearing in any way, shape, or form. All right. When the weight that's out front is hitting the stop that's welded to the gear, then the weight is pushing it forward, pushing against the stop on the gear. So the gear is pushing back, the weight is pushing forward.
Right.
Yeah, it's if you put too many weights on there and too many gears on there, you just can't quite grasp it because it gets too busy. There's too much going on. Bringing it all the way down to just one gear.
The car is, for all purposes, zero, right? Because it's not frictionless, but it is, for the purposes of your experiment, the weight of the cart itself is not.
The weight of the cart is actually important in the fact that because there is pushing of energy, if the energy, this is back to the whole, we're not breaking any laws of physics. If the energy doesn't have something to push against, it will have nothing to pull against.
So restating, if we put the car, if say we got a big hunk of aluminum and build all this stuff on a piece of aluminum,
then we would have nowhere near the propulsive power that we have now.
But if we took a piece of lead,
then we could put a 30-pound weight on this thing and, break all kinds of stuff.
well, I'm just saying, would it move? So basically, there should be a way you could like.
There's going to be a relation.
Do a relationship between the weight.
There is a relationship. It's a mathematical relationship. It's not something that we've worked out because it hasn't been that important yet. This is all going to be worked out for efficiency purposes. All right. But there is a mathematical relationship between the mass that we're moving and the mass that is being moved. So
well,
that relationship has to be.
I want to acknowledge your good work. I think it's baby steps.
Oh,
but
absolutely.
What I really like is your spirit of you wanted it to fly.
I do. I want it to fly. I want this thing off the ground. You bet.
You're starting out crawling, but you're already ready to fly.
Well, think about it. 130 years ago, the first wooden wheeled cars were running down the road with a 3 horsepower engine on them, and they had to push them up a hill. Look where we're at now. I mean,
yeah, originally the electric car was the competition. Remember that?
The electric car was the competition of the day, with a hand wound motor and a couple of permanent magnets.
The top electric car company. Guess who it's named after? Tesla.
That's it.
Well, so guys, I think we're running low on questions, and so I just talked to Mark in chat. I think what we should probably do is give Brian another hand and then just go to open discussion. You guys can keep discussing at that point. Does that sound good, Brian? Or
sure, that's fine.
Okay, well let me do that then. I want to put this on gallery view again. Everyone, thank you again, Mr. Bryan St. Clair.